Hello friends, right in front of you is the model of an RC aircraft which has been manufactured by Aero Modeling Club of NIT Kurukshetra. In this video, I am going to tell you various parts of this aircraft, their function and how this aircraft will be taking lift and the various motions that this aircraft will perform when it will be in the test flight. Starting from the front, we have this propeller motor. This is called the propeller blade, which has a particular profile you can observe in this view. This motor has RPM of 1200. This is the fuselage body of this aircraft. This is a wing having a particular wing span that I will mention you in the later part of this video. This is the horizontal stabilizer. This is the vertical stabilizer. This is called the elevator. This is called the rudder. So these are the basic components. In this fuselage body, we have components like a battery which will provide required power to this motor, 4 servo motors which would be controlling the 4 parts, that is this is one part, this is called aileron, the second part also known as aileron, third part known as elevator, and fourth one called rudder. So these 4 parts will be controlled by the 4 servo motors which are present in this fuselage body. Apart from this battery and these servo motors, we have one electronic speed controller which would get command from the transmitter, which would be in the hands of the person who will be controlling this aircraft. Now I will tell you how this aircraft is going to take lift and what are the functions of its various components. Starting from the front, this is the propeller motor, propeller blade. When this motor will rotate, then it will push away the wind in the backward direction at a high speed. As we have learned by Newton's third law of motion that every action has an equal and opposite reaction, so in turn this complete aircraft body will be getting a particular thrust in the forward direction. This is how this aircraft is going to move. Now since I must mention you that the weight of this aircraft is 1080 grams. This aircraft has been manufactured of balsa wood. The main thing about this balsa wood is that it is very light and has sufficient strength which is required for these aircrafts of small scale. Now this is the front wheel. These are the 2 front wheels. You can see one rear wheels we have mounted here. You can observe. Means totally 3 wheels are here, 2 front wheels and 1 rear wheel. Now we have used these wires. These wires have the diameter of 2 mm which would be controlling these 4 parts. As I have initially mentioned, these wires are directly connected to the servo motors which are mounted here in this fuselage body. Now as we have calculated that for about 1080 grams of this aircraft, initial velocity of 10 meter per second is sufficient for this wing to provide lift. So this propeller motor is also sufficient to provide such velocity to this aircraft. Now this wing has the span of 118 centimeter. This fuselage body has a span of 75 centimeters. We have chosen it on the fact that we know that the fuselage body is about 50 to 60% of this wing span. Accordingly, we have decided this the length of this fuselage body. Now when this aircraft will be having motion, it would be suppose moving at 10 meter per second, then how this aircraft will take lift. See the wing profile clearly, this profile, and see this profile. You can see the below part is a bit flat compared to this upper portion which is a bit curved. I must mention you that we have chosen this profile according to the Boeing 103 plane. So when this aircraft will be moving at suppose 10 meter per second, then the air which is coming from the forward direction will have exactly equal time to pass over both upper surface as well as lower surface. So you can see that in same time air has to cover larger distance on the upper part compared to lower distance on this lower part. So you can observe that the velocity of wind would be more on this upper part compared to that on the below part. According to Bernoulli's principle, we have seen that when the wind velocity is more, then its pressure is going to be less. So you can see there is a pressure gradient, that is higher pressure on the below part position compared to lower pressure on this upper part. So you can see a pressure difference. This is the prime reason why this aircraft takes lift, that is due to this pressure gradient on the opposite side of this wing. Now I think you must have understood how this aircraft will take lift. Now I will explain you the various motions that this aircraft performs when it is in the space. There are exactly three motions. As you all know that there are three axes. One is the x-axis. We have supposed this as x-axis. This is the fuselage axis. Next one is the y-axis, which we have supposed as the wing axis you can take. And next one is the z-axis. Okay, x-axis, x-axis, y-axis, and this z-axis. These are the three axes. Now the motion about this x-axis, okay, this motion is called the rolling motion of this aircraft. This rolling motion would be provided to it by the two ailerons which are mounted at the back of this wing. One is this, it is movable. Also one is here, this is also movable. So these two ailerons are moved in opposite direction so that the flowing air causes opposite thrust, opposite force on the two wings, on the two sides of the wing. Thus a couple will be formed, which will be the prime reason for rolling motion of this aircraft. Now one is the rolling motion, you must have understood. Second one is the motion about this y-axis. So you can see this y-axis or wing axis is the axis about which the motion which would take place is called the pitching motion. Now pitching motion would be provided means motion about this wing axis would be provided by the elevator which is mounted here to the horizontal stabilizer. Okay, when this servo motor will give the command, then it will move up and down, and accordingly the forces which would be acting on this aircraft body, and this body would perform a pitching motion in this form. Okay, so this is called the pitching motion about this wing axis. Then the third motion is called the yaw motion, which is performed about this z axis. This yaw motion would take place in this direction, it would be like in this direction, it would be like z axis. This motion would be provided to it by this rudder which is mounted to the vertical stabilizer. So you can see these three motions which this aircraft would be performing when it would be in space. So these are the various functions that this aircraft will perform, and I have mentioned you about all the components. And one most important thing is the angle of attack. Just observe it keenly, the angle which this aircraft body is making with the ground. This initial angle is called the angle of attack. Okay, this angle of attack is one of the most important requirements for this body to take lift. Okay, this angle of attack must also not be more than 8 to 10 degrees, otherwise stalling of this aircraft will take place. And you must notice that once the stalling has taken place, then it is very difficult for a user to maneuver it in the space, and furthermore the accident of this aircraft will take place. Okay, so you must means I should tell you that we have provided a stationary angle of attack of about 4 degrees. That means this you can see angle with the ground is 4 degrees, and when the aircraft would be in the position to take lift, then we will push these ailerons in the downward direction so that an extra force would be provided by the wind so that our aircraft could take lift easily. That means you can say that angle of attack would be about 2 or 3 degrees. So we would be in limit to 6 degrees of angle of attack. 6 means 6 to 7 degrees of angle of attack, which would fulfill all the requirements. Okay, so these are the various functions, various motions that this aircraft will perform, and various specifications that we have used in this aircraft. Okay, and one last thing, you must see the shape of this body. This is a bit curved here also it is curved. We have tried to provide it a streamlined structure so that when it is flowing in the air, then we must experience the least possible drag. Drag is the force due to air friction. Okay, so in order to get the lowest drag force, we have rubbed this from the two portions so that drag force is lesser. We have never, at all the portions we have provided this fillet, or you can say while you will be manufacturing it in GATE-AIR, you will observe a function called fillet providing, which we have provided everywhere, and we have made nowhere there is a sharp turn which could increase the drag forces. So, and at last I must tell you the various forces that are acting on this body. So one is the drag force that I have right now mentioned. This is the drag force along this body. Another one is the weight of this body, which would be acting in the downward direction. Drag force would be acting in the opposite direction to this motion of this aircraft. Third one is the lift force, which would be provided by this wing. And fourth one is the thrust, which would be provided by this motor, thrust motor. So exactly there are four forces. When the condition is reached that this lift force is sufficient to balance, to overcome the weight of this body, this aircraft will take lift. And as we have calculated, we have performed various calculations, and where we have found out that this motor with this particular profile of this blade is sufficient to overcome the various drag force as well as the weight of this aircraft, so that our aircraft could take lift easily and we can easily maneuver it when it is in space. So this was all about our aircraft, and thanks for watching this video.